So in this video, we'll go through the process of naming a phenol. Phenols are another organic class of compounds that contain a benzene ring, which remember we can also here refer to as a phenol, with the alcohol functional group, so the hydroxyl, directly attached. Anytime you see the hydroxyl group directly attached to the benzene ring, it represents the phenol. So it's basically as if we are combining two previously discussed functional groups. We're combining the phenyl group, which of course was our benzene or our aromatic, with the alcohol to get the phenol. So when naming phenols, just as we saw with naming alcohols that are present in a ring, because the ring could have a carbon at any position to be carbon number 1, with the presence of that hydroxyl group, that automatically assigns that carbon as carbon 1. So when naming phenol groups, it's a little easier than the other molecules because we already know how to number our parent chain. When we indicate phenol, the phenol is going to account for that benzene ring and that OH group that is directly attached. So all of that is accounted for in phenol. The only thing left to account for is whatever's sticking out. So we have our phenol group. We have this one substituent because we have one branch, but that one branch contains 2 carbon atoms, so now we have an ethyl group. We have to indicate where that ethyl group is located. So we know that this very top carbon, because that's where the OH was located, that's carbon 1, we can see that the ethyl is closer to the right side, so that's a clue that we want to number this parent chain in the clockwise direction. Therefore, that ethyl group will be placed on carbon number 3. So now we have our parent chain identified, we have our substituent identified, we know where everything is located, we simply put it together. Just as with the other molecules, you want your substituent to be listed first. So 3-ethyl, followed by your parent chain. No number is needed because knowing phenol indicates benzene with a hydroxyl at carbon number 1. So the IUPAC name for this compound will be 3-ethyl phenol. Another thing to point out, because again I know some people like to look at different YouTube videos or Khan Academy or do Google searches. When dealing with aromatics that involve multiple substituents, there are different ways that you can see it numbered. So if you look this up on the internet, you may also see it referred to as meta-ethyl phenol. Meta, M-E-T-A, is basically indicating the location, and it indicates that they are 2 carbon apart. And so you may also see, while you're looking, you may see ortho. Again, you may see the meta, and you may see para, if you're looking at substituents that are on an aromatic ring. Ortho, meta, para, 1 carbon, 2 carbon, 3 carbon apart. So if we look at another example, again we have our ring, our benzene ring. We can see our alcohol functional group, so we know we're dealing with the phenol. So we can box that area off. We have our benzene ring with the alcohol functional group. Let me include that alcohol. So that takes care of our phenol part. We see 2 branches sticking out of that. This one has 1 carbon. This one has 1 carbon. So they are both methyl groups. Again, anytime you have 2 of the same substituents, instead of writing methyl, methyl, we can show it as dimethyl. Dimethyl just represents 2 of the same, in this case, 2 methyl groups. But we have to indicate where they're both located. So again, we already know that this is carbon 1. Based on the placement, we want to count clockwise, so this would be 2, and this would be 3. We can keep numbering, but we don't really have to because we have nothing else on those carbon atoms. But numbering in the clockwise direction tells us that this carbon is on, this methyl is on carbon 2, this methyl is on carbon 3. So then we can put everything together because we know our parent chain, we know the identity of the substituents and where they're located. So when we put it together, the dimethyl goes first because that's representing the substituent. However, we have to indicate where they're both located. So we have 2, comma, the comma doesn't look very good, but 2, 3 dash dimethyl phenol. This name tells us that we have a phenol group. So we have a benzene that has the alcohol functional group at carbon 1 with 2 methyls, 1 on carbon 2 and 1 on carbon 3. And so when naming phenols, again, your ring, since it can have any carbon B carbon number 1, it's understood that wherever that hydroxyl group is at represents carbon 1. From there, we are just indicating the location of the other substituents. Put them in alphabetical order, include their location, followed by the name of the parent chain, which is phenol.